Welcome back. I want us to look at the solution to this question. That we have a dice here with faces marked 2, 3, 3, then 4, 4, 4. It has 6 faces. The dice is rolled n times, and the probability that on the nth roll it first lands on number 3. And this probability is equated to 32/729. So the question asks us to find n, which is the number of times the dice is rolled. So solution, the first thing I want us to find the probability that a 3 lands. The probability that a 3 lands is the number of faces marked 3, which is 2, over the total number of faces, which is 6. This one gives us a third. Number 2, we find the probability that a 3 does not land. Probability that it is not 3. This one we determine by taking the number of faces that are not marked 3, which means the 2 and 4s, which is 4 over total 4/6 is equal to 2/3 when simplified. Or this one can also be determined by taking the total probability 1 subtract the probability that a 3 lands, which is a third, to give us 2/3. Either way, you get the probability that a 3 does not land. Now, we have n number of rolls, but a 3 lands on the nth roll. It means that in the first roll, second roll, up to n minus 1 roll, a 3 is not appearing. So what is the probability that during the nth roll it is a 3 appearing? It will be the probability that in the first roll, second roll, up to the nth minus 1 roll, a 3 is not appearing, times the probability that a 3 appears in the last roll. So this one would be, let's say, probability that 3 lands on the nth roll is given by probability that it's not 3 in the first n minus 1 rolls multiplied by the probability that it is 3 in the last roll. The question is, how do we determine the probability that is not 3 in the first n minus 1 rolls? Let's take it procedurally, that the probability that it is not 3, probability that it is not 3 in the first n minus 1 rolls is equal to the probability that it is not 3, which is 2/3 in the first roll, multiplied by the probability that it is not 3 in the second roll, multiplied by the probability that it's not 3 in the following rolls, like that, up to the probability that it is not 3 in the n minus 1 rows. This is the first position, or the first row, second row, and then proceeding rows up to the 2 over 3, which is the n minus 1 row. So this is n minus 1 rows. You realize that 2 over 3 is repeating itself. We are multiplying 2 over 3 by itself. So this one we can just write in power form, and it will be 2 over 3 power n minus 1 number of rows. So that now the probability that it is 3 landing on the nth row is equal to probability that it is not 3 in the first n minus 1 rows, which is 2 over 3 power n minus 1 multiplied by probability that it is 3 in the 6th nth row, which is 1 over 3. And remember, this has been equated with 32 over 729. Simplifying, we multiply 3 by both sides. You will get 2 over 3 power of n minus 1 is equal to 32 can be written in power form as 2 power 5 times 3 now over 729 is the same as 3 power 6. So 3 divided by 3 power 6, of course, this 3 power 1 will have 3 power 5 here. So this implies that you have 2 over 3 power n minus 1 is equal to, this one will give us 2 power 5 over 3 power 5. We'll just take this 6, subtract this one. And therefore, this one can be written as 2 over 3 power 5 because the powers are the same. And then the bases here are the same, you equate the powers so that you have n minus 1 is equal to 5. Therefore, n is equal to 5 plus 1, which means n is equal to 6.